Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Have you ever woken up to a crisis because a number on a dashboard is broken and no one knows why, or sent out frustrating Slack messages trying to find the right dataset, or tried to understand what a column name means? Our friends at Atlan started out as a data team themselves and faced all this collaboration chaos. They started building Atlan as an internal tool for themselves. Atlan is a collaborative workspace for data-driven teams, like GitHub for engineering or Figma for design teams. By acting as a virtual hub for data assets ranging from tables and dashboards to SQL snippets and code, Atlan enables teams to create a single source of truth for all of their data assets, and collaborate across the modern data stack through deep integrations with tools like Snowflake, Slack, Looker, and more. Go to dataengineeringpodcast.com/Atlan today, that's ATLAN, and sign up for a free trial. If you're a Data Engineering Podcast listener, you get credits worth $3,000 on an annual subscription. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's LINODE, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host is Tobias Macey, and today I'm interviewing Artom Keydunov and Pavel Tiunov about Cube.JS, a framework for building analytics APIs to power your applications and BI dashboards. So, Artom, can you start by introducing yourself?
Hi, everyone. My name is Artom Keydunov. I'm really excited to be here today. Together with Pavel, I started Cube.JS as an open source project 3 years ago, and happy to share more about it today.
And Pavel, how about yourself?
Yeah, sure. Hi, everyone. My name is Pavel, and I'm co-founder and CTO. And yeah, we started to work with Artom back in the days in 2016 before we started Cube in 2019.
Going back to you, Artom, do you remember how you first got involved in the area of data?
As Pavel mentioned, I met him and I got involved into the area when we started to work together on StatsBot. StatsBot was a Slack application I created in 2016. And the idea was to make analytical data from different places, such as Google Analytics, Salesforce, Mixpanel, accessible as dashboards in Slack, and later in other places, such as Microsoft Teams. StatsBot was installed by thousands of users, and for large users, we started to see many scaling issues, around building efficient pipelines, aggregations, and data modeling to eventually consume data downstream in Slack and Microsoft Teams. And with all of that complexity, we're helping our clients understand how to optimize their data pipeline. That's when I really got involved into the data management area.
And Pavel, how did you first get involved in data?
I was working a lot, back in the days, enterprise software and specifically building BIs from scratch. So before I ever stepped into a startup ecosystem, I was building BIs from scratch for 10 years. Mostly most consulting jobs. So I had pretty decent prior experience with data.
And so that brings us now to the Cube project that you're both working on and that you have started a business around. I'm wondering if you can just give a bit of an overview about what it is that you're building there, some of the story behind how it came about, and why this is an area that you feel is worth spending your time and energy on.
So yeah, you can think of Cube as a headless business intelligence. So it has JSON-based data modeling layer, similar to some other data modeling layers that other BIs have. It has access control management to implement row level and column level security. And finally, it has a caching layer, similar to BigQuery's BI engine. The main difference is that we are API-based, developer-centric. We don't do charts, so hence we are headless. Cube started as a project to power StatsBot, the company Pavel and I started before. And when we were working on StatsBot, we faced a problem that we needed to connect to many data sources, but also to provide a universal facade to all downstream data consumers. In our cases, that were Slack applications, Microsoft Teams, BI dashboards. So we realized that we needed to have a data modeling, security, and aggregation in a single unified layer upstream from the data consumers. That's how we built our Cube initially as part of the StatsBot.
In terms of the use cases and the workflows that it enables, what are some of the primary focuses that you are building around and some of the existing challenges that are in the space that make Cube.JS a potential solution for people who are building their own data systems?
The major use case we started with is embedded analytics. So Cube powers dashboarding and reporting features inside customer-facing applications. Since we are headless, right, we provide only API and some front-end SDKs. Downstream, inside this customer-facing application, our users, they usually use charting libraries like Chart.js or HighCharts or D3 to display data consumed from Cube's API. I would say from data sources, we are mostly focused on data warehouses and data lakes. That's where we see the most usage. We also see some of the usage with transactional databases. Very often, especially recently, our users use transformation tools like a dbt upstream, especially when they use it with the data warehouses. Cube itself is written in Rust and TypeScript, but since we distribute as a Docker container, it really, can fit in any architecture, right? We see companies building in Java, in Node.js, in Python, in Ruby, and they just run Cube as this kind of Docker container inside their architecture. Maybe Pavel, if you have some insights into kind of other architecture and use cases.
Yeah, and there are some really, I would say, advanced use cases we see with Cube, like automation ones. It's quite unusual right now, but looking towards it. And right now, as we shipped our Cube SQL API, which allows you to connect different downstream tools which consume data, this automation becomes much more feasible. One of interesting use cases we saw is basically some automation on top of IoT sensors, which basically will querying Cube on a scheduled basis to trigger some alerts. This one, very interesting use case.
In terms of the audience that you're building for, who are the sort of target users and personas that you think about as you initially built out the project, and now that it's been released as an open source framework and that you're turning it into a business, some of the ways that you think about the personas as you identify potential new features or improvements to add in?
We started with application developer as a persona. We were focused on application developers, but over time we started to see more, data engineers to be involved in Cube-related projects within companies. I feel that we just see a bigger trend that more, data analysts, they are becoming more data engineers, right? We see that, a lot of encouragement in a space for applying developer software engineering best practices into the data space. So I think that's sort of, a trend that affects Cube as well. And we see more and more data engineers using Cube lately.
In terms of the naming, I know that it is inspired by the idea of an OLAP cube, which is a certain way of being able to model your data so that you can answer useful questions in a way that is maybe not as easy to get at or as performant when you're pulling it directly from a transactional system. I'm wondering if you can talk to some of the applications of OLAP cubes and their role in the current state of the data ecosystem and some of the ways that what you're doing in the Cube.JS project makes them more accessible or more relevant in sort of the modern data ecosystem.
Right. Yeah. I'd probably just quickly comment on the name thing, and then Pavel can share his perspective on the OLAP cubes. That's true. The name comes from the OLAP cube, but it's more like when we started to build the cube at StatsBot, we didn't have a name for that project because it was just only, the StatsBot engine or something. But we have this main object in the system, which we called cube. And cubes in Cube, we should probably call it a hypercube or something, but cubes in Cube they map to physical tables in a data warehouse, or, like a derived table that contains measures, dimensions, and join relationships, some sort of abstraction. And we just thought that Cube may be a good name for that because, like historically people used to call things like that Cube. Even if we are not a one-to-one with all up cubes, right? But it's just like something that we thought the closest to the idea of the cube.
Yeah, and also when people hear about lab cubes, they think something about slow, materialized, and really outdated. But in fact, cubes were introduced as a mass concept, is basically coming from multidimensional analysis. And in fact, it means basically a multidimensional data set with variable granularity, which can be provided to users with as a more granular data or less granular data. First of all, it was introduced to solve optimization problem, but it turned out it's actually a very great framework to design and model data.
In terms of the idea of an OLAP cube and what you're doing at Cube.JS and the recent introduction of the idea of a dedicated metrics layer, I'm wondering if you can kind of draw some comparisons across those three elements.
Some people claim that the metrics layer is just, fancy name for OLAP cubes. I think ideologically they are close in trying to solve the same problem to create a data modeling abstraction layer. There are many tactical differences in how they approach the problem, though, mainly because they're from different generations, right? So new tools and new technologies enable us right now to think about these problems differently. So that's why we have, this new way for thinking about dedicated metrics layers.
Yeah, and also this concept of cubes, again, it was back in the days it was introduced, and then for our data community, it's not well used and popular. It is actually used among most of data tools right now because, for example, base parts of a cube, you can find it almost everywhere. It's measures and dimensions. In fact, it is a cube when there is measure and dimension.
As far as the overall sort of modern data stack, as people are starting to coin the phrase where each different concern within the data platform is a separate tool or a different service. And I'm wondering how you see Cube.JS and the Cube Cloud platform that you're building out sitting within that ecosystem and maybe some of the pieces that it either augments or potentially replaces.
We've been thinking a lot about that, especially now with when recently started to see more data engineers use Cube. And when we built Cube initially, we were not optimized for, any, say, transformation upstream, for example, right? We built it the way that people would be able to use it with the raw data without any required transformation in the source system. And people would be able to just define metrics and run pre-aggregations and sort of transform data. But over time, we started to see more DBT users, for example, and we thought that makes a lot of sense. I mean, that's a great tool to run transformations, right? And it could make our lives much easier if people would come to Cube already with transformed data. So that's why right now we encourage really to use DBT to transform data upstream for users to use Cube and then use Cube to actually define metrics and access control and caching if needed. So I think we'll continue to do that, to see how we fit with the different tools. As Pavel mentioned, Cube SQL API is a good example. We don't want to do charts. That's a hard line for us. We don't want to go into visualization business. But there are a lot of great tools, to do that. And BIs obviously, always continue to evolve. And there are some good open sources ones like Metabase or Superset. So we want to integrate with all of them. In fact, we already integrate with Superset. And there are also tools like data apps, right? Like a Streamlit is a good example. So we want to be able to provide APIs and sort of headless abstraction to tools like a Streamlit so they can visualize data downstream. So we kind of, plays in the middleware here. And that's why, the question of how we fit into the ecosystem is really very important for Cube.
In terms of the actual implementation of the platform and some of the design elements that go into how it factors into the data platform, I'm wondering if you can just talk to the architecture and implementation details and some of the ways that the design has evolved or the goals have changed from when you started to where you are today.
Cube has three main components: the JSON-based metrics framework, APIs, and a caching layer. Developers and data engineers, they develop metrics using the Cube metrics framework. Then data consumers, such as BI tools or in-app analytics, they query metrics through the API. It could be REST API, it could be SQL API, or it could be GraphQL API. And finally, the caching layer can be used to cache the metrics calculations to speed up some of the API requests.
And in terms of architecture, we decided to go with very distributed architecture, like modern BI stack. So Cube consists of, first of all, of horizontal layer of API instances, which can scale horizontally and handle hundreds or even thousands of basically queries per second. Then there will be a layer of basically caching layer. So API instances can go directly to raw data or either through cache layer. And the cache layer is a distributed cache layer called Cube Store. It's basically really tailored towards to work with data warehouses on a scale. So it is designed to provide like fixed response time on basically unlimited scale of data. And we are aiming like billions of rows per single table. And we also have refresh workers, which basically populate cache in the background. So that's high-level architectural view.
And so you mentioned that one of the core elements of the architecture is the caching layer that you're using to improve the overall performance for people who are using the API for either powering user-facing applications or to accelerate the display of dashboards in the business intelligence layer. And as everyone who has worked with computers long enough knows, one of the hardest problems in computer science is cache invalidation and making sure that things are up to date and that you're not holding on to information too long, but that you're also making sure that you pull in the information that you need ahead of time. And so I'm curious how you have approached the overall challenge of making sure that you have the right data in the cache in that pre-aggregation layer so that people can answer the questions that they're looking to answer and then still being able to have a graceful degradation when they're starting to dig into information that isn't already available in that cache.
Cube pre-aggregations, they're sort of materialized tables layer. So we aggregate data first in source data warehouse and download it, reformat it for fast querying, and then insert into our cache layer. And Cube manages all the orchestration of that process. The way the refresh works is either the time-based, when users define the interval to refresh, like every 2 hours or every day 8 a.m. Pacific time, or it could be based on the condition in a source data warehouse. An example here would be to check for the max timestamp in a table, and if it changed, rebuild materialized table in cache.
Yeah, and from technical perspective, under the hood, it's actually materialized and it's persisted as Parquet files. So it's columnar storage on a scale. We use distributed file systems like S3 or GCS or MinIO to basically provide the storage and the separation of storage and compute here. Basically, when these tables are queried, we have partially in-memory cache. All the basically tables are warmed up on multiple nodes, and it's basically Cube Store designed to work on dozens and even hundreds of nodes to distribute all load horizontally. So every query can be answered with a fixed response time, and basically we are aiming for sub-second response time here, and basically scale really to large data sets like billions of rows.
Given that you are materializing the information into the Parquet files and distributed storage, how do you make sure that you are cleaning up those files after they've been invalidated so that you don't have them laying around and costing extra storage space and money, or potentially polluting the cache with mismatched data because you're accidentally reading some older cache files when there's a newer cache file available, and just the overall kind of management of that lifecycle?
This is why we have these refresh worker instances. So they are basically the process which runs in the background and checks freshness of all data pieces. So it is quite usual that people will use partitions and partition data fetch in order to minimize their cost for refresh. So when you have, for example, time series data, you don't need to refresh a whole table over and over. You need to refresh just a delta for just recent data in case you have other data is immutable for you. This refresh worker just marks basically partitions for garbage collection, and in the background there is hot swap between newer partitions. Once new partitions arrive, 10 minutes after that will be all partitions will be garbage collected. But for user, it's basically transparent.
And in terms of the overall kind of design philosophy and user experience for people who are building on top of the Cube.JS platform, and for people who are designing the data aggregations that they want to expose, how do you think about the overall usage and design elements and developer experience for people who are integrating Cube into their data platforms?
Overall, we try to advocate for applying some software engineering best practices to data space in general. I mean, version control, isolated environments, and we making all these required primitives in Cube to make it very easy to follow best practices while working on Cube projects. We are developer-centric and everything is code-based. Metrics definitions and configuration, so code-based, and usually it's being stored in a version control system. In fact, our cloud product is just fully based on the version control system. So even if you're not using any Git today, right, the Kube Cloud will still store everything as a Git project. We also always try to stand sort of on the shoulders of the giants here in terms of the API design and rely on existing solution and best practices and ecosystem as general. An example here would be the way we manage access control in Cube. We rely very heavily on JSON Web Tokens and its ecosystem, because it seems to be sort of the main kind of a standard of access control tokens in the web application nowadays.
Because of the fact that you're sitting in this in-between layer of the data storage and the sort of data visualization or downstream consumers of the information, what are some of the points of tension or challenges that introduces, because of the fact that you have to deal with such different audiences, both in the producer and the consumer layer, as well as the differences in terms of expertise, as far as data engineers and data analysts are going to be very familiar with data modeling and how things live in the data warehouse, whereas if you have business intelligence engineers or web developers who are consuming the API, they're going to have a much different set of expertise in terms of how they're accessing the data, and just some of the ways that you think about the collaboration across that boundary.
It's kind of hard because we exactly try to make this bridge between all the data people and applications web developers. They have a different expertise on both ends. We have many conversations with data people when they mention they don't have enough, experience, skills, or even bandwidth just to build something custom on the front end, right? That's why they want to have existing tools like BIs to work with Cube, or the data apps like Streamlit. That's the whole reason why we released the SQL API, to be able to connect to these BIs. On the other hand, with front-end engineers, sometimes, land to use Cube in their projects to power dashboards, they have a very limited knowledge and understanding of the data, right, and data modeling. In that case, it's a lot of challenges to make product to help them. because you still have to write SQL, right? We don't try to replace SQL. It's basically all SQL based. So it's not an easy solution here unless to make it more, content and just best practices around that. I think what also helps is when you mentioned before that sort of, explosion of the data stack right now and every tool solves its problem. And again, I've mentioned dbt before, but I think dbt could be very helpful in that case too, right? When tables already transformed upstream by data team, and then application developer can just leverage Cube and plug to this transformed tables and do just, one-to-one mapping of the cubes to tables. And they would not need to write all the custom SQL. That would help to speed up the adoption and the development cycle of the cube. So that's kind of why I'm excited to plug into more and more tools to kind of leverage and speed up the development process.
Yeah, and also Cube helps actually bridge a gap between these data engineering teams and front-end teams, because once you define your data model using cubes, so there is an API layer for that, which you can set in place and fix, so front-end team can rely on it. But the data, basically, which goes into these cubes, is very flexible. So data engineering team is not tied to the data definitions, transform tools they use, or even databases they use. So they can replace it. While a front-end team is fixed on an API layer and can be sure that it won't change.
Modern data teams are dealing with a lot of complexity in their data pipelines and analytical code. Monitoring data quality, tracing incidents, and testing changes can be daunting and often takes hours to days or even weeks. By the time errors have made their way into production, it's often too late and the damage is done. Datafold's proactive approach to data quality helps data teams gain visibility and confidence in the quality of their analytical data through data profiling, column-level lineage, and intelligent anomaly detection. Datafold also helps automate regression testing of ETL code with its data diff feature that instantly shows how a change in ETL or BI code affects the produced data, both on a statistical level and down to individual rows and values. Datafold integrates with all major data warehouses, as well as frameworks such as Airflow and dbt, and seamlessly plugs into CI workflows. Visit dataengineeringpodcast.com/Datafold today to book a demo with Datafold. And as far as the workflow of actually building out a set of metrics and API endpoints for being able to consume in some of these downstream applications, whether it's the business intelligence layer or an embedded analytics use case, I'm wondering if you can talk about some of the considerations as far as data modeling in the source systems, some of the ways that you're approaching the actual cube definitions and how that maps to different API endpoints, and some of the considerations that go into that mapping as you're building that out, and just the people involved as well at each of the stages of sort of defining, designing, and implementing these endpoints and the metrics that they're pulling from.
I feel the first step would be to connect to the data warehouse. Obviously, once we have that connection working, we would need to build at least one cube. We have up to generation of cubes from tables in a data warehouse, so it's very useful to quickly bootstrap and generate some simple cubes with basic measures like count and dimension just being mapped to columns. Overall, we can think about cubes as kind of an abstraction layer that usually maps to physical tables in a data warehouse and creates all these measures and dimensions as the metrics on top of cubes. Once we have at least few cubes to play with, we can test them in what we call a cube playground, which is a developer sandbox tool to test metrics definitions. And once we satisfied with our metrics, we can connect to cube from downstream tool, for example, from Apache Superset. In that case, we would connect through the kubesql API. It's basically a MySQL connection. So from Superset, we would need to connect to Cube as to MySQL, specify host, user, password as usual. And now cubes will be treated as tables. And users will be able to use Superset UI to click and select what they wanted to query and build charts and dashboards. They would also be able to craft a SQL by hand. The only caveat here is measures, because measures, they are already aggregated within Cube, it doesn't make sense to run aggregate functions on them again, right, when querying through kubesql API. But for compatibility with downstream tools, Kube supports aggregate functions on measures, but as long as they match the measure type. For example, if you have a count measure, you can use only count aggregate on this measure, and you cannot use a max or min, and Kube will return the error saying you this. So yeah, that would be an example of querying from the BI tool. For in-app analytics, it's usually either REST API or GraphQL API. Users will specify the measures, dimensions, filters they want to query in a request, and then Kube will process the request, use the metrics definitions, generate a SQL for the data warehouse, execute that SQL, and then sends data back. And finally, users, they will be able to use any charting libraries they want to visualize this data in the application.
So once people start deciding that they want to use Cube.JS and they've built out an initial proof of concept of here's a single metric and a single endpoint. So I've been able to prove out that I can actually connect to my source system. I can build a Cube definition and then access it in a downstream system. What are some of the iteration cycles of going from that initial proof of concept to a more sophisticated and widely deployed usage of Cube.JS, both in terms of the infrastructure management that goes into it and also the kind of developer cycles of being able to maintain the existing definitions while they add new ones without breaking potential downstream consumers?
There are mainly three areas work. Here is data modeling, security management or access control management, and caching configuration. So data modeling is foundation of the everything, right? Once you have our first metrics, we probably want to add more and more metrics. So iteration cycle will usually involve changes in a data model, creating and updating metrics, and then testing them, then applying security rules if needed, and then finally caching if required. These areas can go very deep depending on the sophistication of the use case. If it's embedded analytics, it's usually very multi-tenancy driven. Different users, they can have different databases, different users, they may have different metrics. So there's going to be a lot of configuration around dynamically generate metrics, dynamically update them, connect to different databases for different data. In a more like a BI use case, that would be more like just a data modeling issues, like how you structure your metrics. So it can be very easy consumable by people downstream in downstream tools. But overall, we try to follow, like best practices in just a general kind of the flow of developing software, because everything is code based. The iteration looks like you do changes in the code, you test them. And once you feel confident, like you go into the staging environment and you test them not to break production. For that, in a cloud specifically, we run isolated environments, which are Git based. So basically, usually run your production environment from the master branch. And when you want to make it changes, you create a feature branch, you do all the changes in a metrics framework in a different branch. Then you deploy that branch in the same sort of, like configuration as you have a master to test. You can run some end-to-end test against the API. You can hook up it into your BI dashboard to test that everything works and you didn't break any old metrics. And once it's, like ready, you can just merge to the master and then we will deploy it to the production. So again, it's very developer centric and everything is code based. So that's why we try to follow the best software engineering practices.
Yeah, and from infrastructure perspective, there is a lot about versioning of changes. So because when you just add new definitions of like members, like measures or dimensions, it's simple. So it's usually no operation. But when you change definitions, it becomes much more trickier, especially, for example, if you have cache in place. So it is usually you want to deploy as a blue-green deployment here. So, for example, you have really high load production in place and you don't want to interrupt your users and you basically want to replace one definition with another one. So what we have in Cube Cloud, for example, is basically a feature called pre-aggregations warm-up. It is basically takes your new version of deployment, which should be deployed, and in background, it just warm-ups all the cache, basically all the new cache definitions you just defined. And when it's done, it just switches API version from basically one schema to another. So in that way, your users even cannot notice any difference and just start receiving like new numbers like instantly.
Another challenge of the sort of development of data applications like this is making sure that you are matching definitions and metadata, particularly across those boundaries that we talked about between the data producers and data management professionals and the application developers and business intelligence engineers. And especially because you're dealing at an abstraction layer of the SQL and the database layout and the warehouse, how are you working to ensure consistency for people who are building these cube definitions and the API consumers and ensuring that you have that correctness from the data warehouse through to the dashboard?
We started to see that question many times in the community. I think, overall the general space of data observability with data lineage started to kind of grow, and it has very interesting tools that people use nowadays. So we don't provide a lot of out of the box right now to do that. So we provide a meta endpoint, which, users can introspect the schema and sort of, build their own metrics catalogs and kind of test it. But our plan here would be to integrate with more data lineage and data observability tools so they can work with Cube. So end users can be sure that, all of the data is in correct state and it goes from data warehouse through Cube to the final destinations. And it's all correct and it's all tested and it's all predictable. So it would be an interesting journey for us to integrate with all of these tools. Excited about it.
As far as the kind of visibility aspect too, I imagine that ties into your goal of integrating with some of these data lineage tools as being able to understand as a consumer of these APIs, I want to see what are all of the definitions that are available for the different metrics or cubes that I want to consume from, and just being able to see at a glance, this is the piece of information that I care about. So this is what I want to pull into either this business intelligence dashboard or this axis of the chart that I'm developing.
I think that there are two things to it. One is obviously can be solved by integrating with data observability and data lineage tools. But there is also a second part, which is more about the metrics catalog, and which is kind of connected to the documentation piece of it, where people want to understand and to learn what metric they have and how they can query them and maybe add some annotation layer to it. So we know that our community shows us that they want it. We know some companies already built something like that on top of Cube introspection API. We want to have it as a part of our product eventually, some sort of a metrics catalog or data catalog. What we don't want to do, we don't want to do what data observability and data lineage tools do. So the first, we probably try to understand where the boundaries is and what makes sense for Cube to build in that area of visibility and metrics catalog. And then once we kind of define the scope, we'll go and build that features in Cube.
In terms of the composition of metrics, I'm wondering how you approach the ability of users to be able to say, I've got this cube that pertains to this particular attribute of my business. So maybe this is the way to identify unique customers. And then I've got another cube that is a way to identify the number of sales for a given period. But now I want to be able to compose them together to be able to aggregate the sales by unique customer and then present that to the business intelligence dashboard, and just some of the aspects of being able to build some of these higher levels abstractions from more granular building blocks.
That's something that people definitely want and need. Right now, what's possible already in Cube is it's possible to join cubes. So if we have like a sales cubes and we have a sales people cube, we can join these two cubes to attribute sales to some specific salesperson and to see, like who is the best performing salesperson right now. So that's possible to join cubes already, just as regular tables. What we're thinking of is mainly two things. One is sometimes it makes sense to join cubes in a different context, right? Like just to create a different compositions of the cubes, and which will create some additional context. Like we wanted to see this 5 cube in a context of marketing and join them all one way. And then we wanted to look at these cubes from a different context and join them a little bit differently and maybe add some more cubes here. So kind of additional abstraction on top of this. So that's one thing that we're thinking right now. We don't have that abstraction layer in the cube, but that's something that it seems needed from our users. And a second area here is more like composite metrics, where like measures dimension, that's a fine. They are very granular, but what if we wanted to go up and say what our best performing acquisition channel, right? Like what is that? Is it a question? Is it a metric? How that should be composed of more granular objects? So that's something that we're working on right now and thinking about what tools we can build in cubes to let users express that higher level abstraction objects.
The other interesting problem that you're taking on with the cube problem is the idea of how to embed the SQL dialect in a sort of host language or host data structure in a way that doesn't drive the end users insane. And so I'm wondering if you can talk to some of the ways that you think about how to manage these SQL statements and SQL fragments and being able to build up the logic in a non-SQL dialect in a way that is approachable and maintainable, and just some of the utilities that you and the community have built to reduce the level of friction when trying to create these definitions.
I think that's a real problem and something that, like we take seriously in trying to figure out what would be the best way to solve it. I mentioned the dbt integration before, right? I think that's sort of one area that it helps too, because if you transform everything upstream already, what you do in a cube, you mostly just point to that transformed table and say my user's cube will be built out of this user's table in my data warehouse, which is already transformed with dbt. But you would still need to write some SQL for dimensions and measures, and you need to embed that SQL. One thing we're working as part of the cloud is kind of Cube IDE, where we help to write and do all these useful tips to, to show what could be done here. I think there is like some ongoing work in the community around types to provide, more plugins to the IDs, like a VS Code or something, so you can have like autocomplete or some useful tips too. Maybe Pavel, you have heard something interesting in that area from the community too?
Yes, some other examples of it, I guess, from what we see in the community, a lot of interest, support for various, I would say, dialects of schema flavors. So we have requests for ES6 support, TypeScript support, and also we are looking towards supporting dbt as a main layer of basically metric definitions. And that way you can combine basically your definitions on a dbt layer, which is basically in YAML, combine that with cube definitions in cube itself, because they can be mixed and like a compound definition. And that way you'll be having metrics definitions in dbt, which is really tied to your data. And on the other hand, you'll be having definitions or a cache layer on a cube side. So this type of stuff we see among the community, like really demanded features and many more formats like YAML itself, like to use with a cube.
And in terms of the kind of development and management and deployment of a cube platform, obviously there's the open source offering, but I'm wondering what you see as some of the challenges that end users face, or some of the points of friction that they encounter when they're trying to get it set up for themselves, and some of the ways that you're hoping to alleviate that with the Cube Cloud platform that you launched recently.
We indeed launched our cloud platform recently to tackle some of the issues we found when we were like working with open source users in a community. They are around both developing and staging and even going into production. I think the main issues that we see is how to apply and how best engineering practice to work with Cube projects. Like, what would be the best way to test changes in a cube reliably to create isolated environments? What is the best way to trace issues and debug, like slow queries and understand why they slow and what you can do to improve the performance of that queries, and also around the collaboration of the features and how, like more visibility into caching layer. And probably the major part is infrastructure. Cube has a lot of moving parts as an infrastructure project. It has refresh workers to keep the cache warm. It has API instances it needs to auto-scale and load balance the load of API requests, but also the memory footprint of the metrics definitions, because it can get quite big, especially for multi-tenant application. And then eventually the caching layer itself, which is sort of distributed query engine, which is backed by distributed file format. So there are a lot of moving parts, and there are a lot of questions how we scale caching, how we scale API instances. So our idea for Cube Cloud was to let's solve all these infrastructure issues so people can just run Cube and don't worry about the scaling and provisioning and management, but also provide them a lot of tools to follow these engineering best practices, like how we create a separated environment to test our changes, how we debug issues, how we have more visibility into caching layer and all of that. It's very new to us. Again, we just launched it, but I truly believe that Cube Cloud is just the best way to develop and run Cube applications in productions.
In terms of the usage of the Cube platform and some of the ways that you've applied it, what are some of the most interesting or innovative or unexpected ways that you've seen it applied?
I know one use case I would love to share about. Just one like large tech companies, they're building an internal end-to-end data platform for data transformation, data modeling, pipelines, and data quality management. I cannot really share a lot about it, unfortunately, but they will open source it soon. So then I will be able to. But we're excited about it because Cube is the core component of that system, and it's which is responsible for the metrics layer. And it's great to see how Cube can power kind of a larger end-to-end data platform.
In your own work on building the Cube project and starting the business around it and launching the platform, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
One of the trickiest stuff we actually bumped in the early days, it's probably quite simple problem and every data engineer had, but really tricky to solve in universal way. So the problem is called either row multiplication issue, or either it's also called sometimes fan out issue. So when you are joining some tables together and you're trying to calculate a metric on the side where it's one too many from side where it's one, and this metric is multiplied. And it turns out that's not a lot of tools in SQL to address this problem because it was never designed to handle this analytic stuff. In Cube you can see really tricky SQL that generated for this use case, but it is generally solved in Cube.
And so for people who are interested in being able to have a shared abstraction layer across their data infrastructure or their application databases, and they want to be able to access things either via SQL or via APIs, or they just want to be able to build a data-powered experience for their end users, what are some of the cases where Cube is the wrong choice and they might be better suited with either a different metrics layer or building something in-house or some of the other patterns that we've seen in the data ecosystem?
I think if the organization is very small and they just rely only on one PI and they don't need to use any other downstream tool, maybe they use Looker right now, right? Which has sort of a metrics framework in it already. Maybe that would be a better choice, like if it's all like everything in there and they don't need to consume the data in other downstream BI tools or applications, and they satisfied with the UI of Looker, that's probably where we don't really need to use that, and they can use this other metrics framework The other use case, which may sound weird, like so many people try to use Cube for like a CRUD operations and ask us, hey, can I write data back with Cube and just create some sort of, just create, read something and update? Cube is not good for it, and we never will make it. So Cube is kind of, sometimes we call, there is like an OLTP workload, right? And it's like OLAP workload. Cube is really OLAP workload, not OLTP. And we like to pair with tools like Hasura to create this abstraction data access layers through GraphQL for all the CRUD-related things. And then Cube really can power the analytics part of it.
And so as you continue to build the Cube.JS framework and open source and build the cloud offering and grow the business, what are some of the things you have planned for the near to medium term, or any projects that you're particularly excited to dig into?
I think that first, like core areas of a Cube where we provide most of our value right now, metrics definitions, security, and caching. And I think even in this conversation, we touched a lot of things already that's sort of on our roadmap, like a data catalog or more abstractions on top of cubes to build this joint context. We definitely want to continue to improve the areas where we provide most of the value. But also, I feel that because we are middleware, we need to be very native in the ecosystem and integrate with as much tools as possible, both upstream and downstream. For upstream, it would be more data warehouses, more databases. I'm particularly excited about the streaming space, and I know there are a lot of great companies that doing interesting things in a SQL over stream space. Well, KSQL DB was around obviously for a long time now, but there are like some companies like Materialize and others that I'm really excited about, and we'd like Cube to work on top of them. I think it will open a lot of new opportunities for real-time analytics, and we will be able to bring that, like upstream from the stream processor to all of BIs and all of embedded applications through the Cube and make it real-time. That would be really, really great. Also, integrations with tools like a GPT for us would make a lot of sense upstream. And downstream, it's more like we follow users mostly here in terms of what kind of tools and how they want to consume Cube. Downstream BIs is the biggest one, probably thing on our roadmap right now. We just want to make sure that every BI works great with Cube. And then we'll want it to look more in the reverse ETL tools. So, users would be able to use the same metrics they defined in Cube, but to run a reverse ETL process and to get data through the Cube into the CRM, so marketing automation. So, yeah, again, would love to have more and more integrations with ecosystem.
Well, for anybody who wants to get in touch with either of you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get each of your perspectives on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I think there is an interesting space, which some people would call data ops or DevOps for data, where the main idea is how to apply software engineering best practices, version control, automated end-to-end testing, isolated environments to data teams and workflows. It feels like there is a need of gap for tools to solve these problems. It's very, very early, but overall direction just feels right. I know there are some great and smart teams like Miltano actively thinking about that problem. So I'm excited to see how this space would develop.
I think it would take some time for all of those folks which are very early, like in data space itself, very early to figure out all the integrations and interconnections. So as we mentioned, a lot of these DevOps tools and basically all of those data observability tools is just getting ramped up, and will take some time to figure out all the interconnections in ecosystem here.
All right. Well, thank you both very much for taking the time today to join me and share the work that you're doing on Cube.js and the Cube Cloud platform. It's definitely a very interesting project and one that tackles a very interesting problem space. So I appreciate all the time and energy you're putting into that, and I hope you enjoy the rest of your day.
Thank you.
Thank you for having us today.
Thank you for listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.